Now, in the second half of this problem set, we're going to look at a very powerful technique known as the distribution rule or distributing. It's basically going to apply when you have sums, things added that are inside a parentheses that are multiplied by something else. And you'll see some examples here in a moment. I just want to point out that the distribution rule is going to look like a lot more work than just doing plain normal multiplication. And I'm going to admit that it is, right? What I want to emphasize here is that there's always two ways to do multiplication. There's the straightforward arithmetic, just multiply the two numbers, get the answers. And then the distribution rule is kind of a long way, a longer path to arrive at the same answer. So if your brain happens to be engaged right now, you might be questioning, well, why are we going to do things the long way when there's a short way that works just as well? That doesn't make any sense. So think of this analogy. Imagine you arrive home and maybe your favorite television program is about to start and you realize that you've locked yourself out of the front door. You can't get in the way that you normally did, but you know maybe that the back door is open, and if you walk through your yard, maybe climb over your own fence, you can gain access to your house through the back door, right? So every system has a front door and a back door, whether we're talking about math or computers, right? There's always a front door, there's always a back door, and in this case, arithmetic, just multiplying two numbers represents the front door. The more difficult way to gain access to the solution is through the back door, which in this case represents algebra, the distribution rule. So what you're going to find out in some cases, once we start to get into algebra, because what we're doing today is really arithmetic, it's not yet algebra, but when we do get into algebra, essentially the front door is going to be locked. You won't be able to use arithmetic to solve the problems, but there is a longer path through the back door to arrive at the same solution. So what we're really practicing here with the distribution rule is learning how to get into the system using the back door, right? It's admittedly a longer, more complicated path, and yet that's what algebra is, right? When you can't go the direct route through the front door, sometimes you need to be a little sneaky, find another way around to get to the same place that you would have been, and that's what we call algebra. Now in this problem, we're looking at the more traditional use of the distribution rule. You'll notice that each of the problems in parentheses, we have two numbers added together, in this case 1 plus 3 and 2 plus 4, and then the parentheses imply multiplication. So again, parentheses are just another way to do multiplication. So there's some instructions. We want to expand each of these into the sum of four numbers, show that we know how to distribute. There's this acronym FOIL, first, outer, inner, last. I'll explain what that means in a moment. It's not math, it's just a trick, a mnemonic device to help you sort of memorize what to do. But the basic idea when you're distributing, when you see this sort of setup, two sums multiplied, you can multiply all possible combinations of the numbers and add them up. So let's look first at the traditional arithmetic approach. 1 and 3 is 4, and 2 and 4 is 6. So when we multiply 4 and 6, we should expect to get 24. But let's apply the distribution rule, see how this plays out. And I encourage you to do it both ways until you convince yourself that this really works. You definitely want to do the distribution way because, again, this distribution is going to kind of be your key into the back door of solving an algebra problem, right? When we get to algebra, this isn't algebra, this is just arithmetic. You're not going to be able to do the straightforward arithmetic, and you're going to find here in the problem sets that follow that the distribution rule is one of the more powerful rules that really allows algebra to work. So the F in FOIL means that we multiply the first two numbers. 1 is the first number in the first parenthesis, 2 is the first number in the second parenthesis, so we're going to have 1 times 2, and notice that a dot is another way to write the parenthesis. We're going to look at the outer product, the O in FOIL. That's the numbers on the end, the 1 and the 4. We have 1 times 4. We're going to add that. And then the I represents the inner pair. The two numbers on the inside closest to each other, we have 3 times 2. And we're going to add that onto the sum. And then finally, L stands for the last. So the 3 and the 4 are respectively the last, the rightmost numbers in each set of parentheses. So the final term in the sum is going to be 3 times 4. And notice how, as advertised, this of course is going to expand out to the sum of 4 things multiplied together. So got an extra step. 1 times 2 is 2, plus 1 times 4 is 4, plus 3 times 2 is 6, plus 3 times 4 is 12. Let's add it all up. We got 2 and 4 is 6, another 6 is 12, and 12 and 12 is indeed 24. We got a little bit of work on the paper, and it's always nice to distinguish your final answer from the work, maybe by putting a box around it. So in the second problem, we have 4 times 3, the first, plus 4 times 1, the outer, plus 3 times 2, the inner, plus 2 times 1, the last ones. And so we have 12 and 4 and 6 and 2. So 12 plus 4 is 16. 16 and 6 is 22. And 2 more is going to give us 24. Check that. 4 plus 2 is 6. 3 plus 1 is 4. And again, we have 6 times 4 is 24. So notice what happened in these first problems. We have 1 plus 3 times 2 plus 4 versus 2 plus 4 times 1 plus 3. Notice that we switch the order of multiplication, which doesn't matter. We've also switched the order of addition, right? We can add in any order. We can multiply in any order. So these are indeed the exact same problem written in a slightly different format.